Welcome to homework.
Small m with the mass of the beam and capital M with the mass of the piano. And Fl and Fr are the vertical forces on the beam on the left and right side respectively. So we calculate the torques about the left end of this point, and I'm taking counterclockwise to be positive. You can choose this to be negative and take clockwise to be positive. It's just a choice. So yeah, now uh, the conditions for the equilibrium are used to find the forces that the support exerts on the beam. So let's first write the torque equation. So net torque should be 0 because they are in equilibrium. This implies, so we are taking the torque about the left end. So let me just write L here. Now about the left hand we have Fr times L, which is giving a clockwise torque, and we have small mg, the mass of the beam, which is giving, FRL is giving an anti-clockwise torque, and mg will be giving a clockwise torque. So this is there should be a negative sign here, and the distance from the left hand side, perpendicular distance, is half of L, because mg is the force is from the center of the beam, which is this mg is from the center of the beam, so therefore the L over 2 minus capital Mg times the perpendicular distance, which is L over 4. This is equal to 0. From here we can find Fr, which comes out to be half of small m plus 1/4 of capital M times G. And we have the following values for small m and capital M, and G is just acceleration due to gravity. So we plug these values into this equation and we get Fr to be 1300 Newton. So this is the vertical force on the right hand side. Now we follow the same procedure and find the torque about the right hand side of about the right end of the beam, and this torque should also be 0 because there is no movement. So this implies, so we have FL contributing to torque, and this is clockwise, so therefore we should put a negative sign. We also have mg times 3L over 4. So 3L over 4 is the distance of mg, perpendicular distance from the force capital Mg and the right end. So basically this distance, which is L minus L over 4, and this comes out to be 3L over 4. And this torque is anti-clockwise, so there is a positive sign, and there is one more force, small mg, contributing to torque. So we write that down. From here you'll get FL to be equal to small m plus capital M So FL will be half of small m plus 3 over 4 of capital M times G. And this will come out to be 2 point, basically 2890 Newton. So this procedure that we did over here, so instead of this, you can always apply Newton's second law, which says sum of net forces is equal to 0. So you can use this equation in the vertical direction using the value of Fr that we got here. And so from this equation, the net force, including all the directions, the vector sum of all the forces should be 0. And from that equation, you can also find FL, and this should also come out to be equal to this value. So these are the vertical forces that are on the supports. So yeah,